and polonium isn't a gas, so the polonium stays in our lungs. And it starts spitting out radiation because the polonium turns into astatine and bismuth, and another isotope of polonium, and eventually winds up as lead. So each one of these stages, it spits out more radiation. So if we breathe in radon, we can get a pretty significant dose of radiation, which can contribute to lung cancer. And this has been measured. People with a lot of radon in their basements, they have an increased incidence of lung cancer, almost equal to, or I should say, comparable to smoking cigarettes. So what they do now is they do tests, and if there's radon in your basement, they install radon abatement pumps where they pump the air out from around your foundation and blow it out through a pipe in your roof and just blow the stuff away. Um, so a lot of you have these in your basement. It looks like kind of a fan that's running all the time, and it's pumping the radon gas out from your basement and keeping you safe. Works well. The point of all this is that when a radioactive isotope decays, it might turn into another radioactive isotope, which has its own half-life and is going to emit more radiation. And this is true of the materials that come from nuclear fission. So when uranium-235 uh, breaks into like the xenon and krypton that we talked about the other day with nuclear fusion. Well, those xenon and krypton, those are radioactive. They have half-lives. Strontium-90 is one of the things that comes out of nuclear fusion. And there are a couple of dozen of isotopes that come from nuclear fission, I should say. I think I just said fusion, but I meant nuclear fission. There are a couple dozen isotopes that come from uranium fission, come out of nuclear reactors, and they are all radioactive. They all have half-lives. They are all spraying out dangerous radiation, and they do it for a long, long time. So that's the problem with nuclear waste. Okay, now this is an activity that we used to do in class, but we just don't have time because of the shutdown. So I'm going to show you very briefly. But if suppose we have 16 grams of a radioactive isotope, and we know that isotope has a half-life of 2 days. The question is, well, how long will it take until we have only a half of a gram of that isotope remaining? And the way we do it is we make this chart, and we say, okay, 0 half-lives, no time has passed. We've just started with 16 grams. So when we start the clock, 0 half-lives have passed, no days have passed, and we have 16 grams remaining. Now, if we wait for 1 half-life, well, that's 2 days. So after 1 half-life, 2 days have passed, and we have half of the original sample left. So we had 16, half of it's left. We have 8 grams left after 1 half-life. After another half-life, we have 4 grams left. After one more half-life, we have 2 grams left. Then 1 gram left. Then 1/2 gram left. We want to know how long it takes till we have that 1/2 gram left. And if we count it out, we see, well, it's 5 half-lives. 0 half-lives, we had 16 grams. After 1 half-life, we had 8, 2, 3, 4, 5 half-lives. We have half a gram left. And since each half-life is 2 days, that means it took 10 days for the sample to decay to a half a gram. Okay, now this would be a very short half-life, pretty dangerous stuff, but we can do the same thing in terms of years. What happens if a half-life is 2 centuries instead of 2 days, or 2,000 years instead of 2 days? Well, then to reduce the sample to a half a gram would take maybe 10,000 years or 1,000 years. But this is the way we can figure out how long a particular isotope will remain radioactive and remain dangerous. Okay, now what about nuclear waste in general? How long does it last? Now I'm talking about the nuclear waste that comes out of nuclear reactors like Millstone and nuclear submarines and things like that. When the uranium undergoes fission, it turns into these radioactive isotopes. I'll come back to this slide in a minute, but the answer is about 100,000 years. This is kind of a rule of thumb. It's kind of an estimate, but the idea is, the belief is, that's not just a belief. I mean, the math shows that this radioactive waste is going to be deadly for about 100,000 years, meaning that if you have it in your basement, you don't want to live in that house anymore. If the stuff is in your soil, in your land where you live, in high enough levels, like it, if they took the lid off of a nuclear reactor, how long could it be before you could live on the land where that nuclear reactor is if all that waste is still in there? Well, the answer is about 100,000 years. That's how long it stays dangerous. Um, Now, what are we doing with this waste right now? This is going to bother you. We don't do anything with it. Some of it is buried in underground storage in different sites around the country. There's some places in Washington where they did bomb research in World War II, and they just buried the waste in these tanks. These are some of the actual tanks that they did, and they just buried it underground. And this is not a good solution because some of those tanks are leaking. This picture right here is a time when they dug up those tanks and moved the waste because they realized it was leaking. That's this. I think this graphic I think I can expand this out a little bit. I'm going to put it in front. Um, Bring it to the front, and we're going to expand this out so we can see it. Okay, the idea is you have this buried tank. Well, the tank rusts and the stuff starts leaking out and seeping down into the ground, and it starts to get into the groundwater, and then the groundwater starts carrying this radioactive waste, Lord knows where. And if you're living downstream of this stuff and you get your water from a well, you're in trouble. Now, they had the good sense to bury these tanks many, 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 many miles from where anybody lived because the research was secret and they didn't want to poison anybody with it. But yeah, this is not good. So these tanks, I'm going to undo these things to reproduce the slide here, recreate the slide. When they were doing this, I mean, they've cleaned this up in the sense that it's no longer leaking into the groundwater in that part of Washington. But obviously, this is not a long-term solution. Um, a large amount, most of the nuclear waste that comes out of nuclear reactors now, like at Millstone, and I don't know if this is done at Millstone or not, but at many nuclear power plants it is, they keep the nuclear waste at the site. They keep it in giant swimming pools. They look like giant swimming pools because they can store this waste underwater and the water will block the radiation. And what they do, the original plan was they would store this in these swimming pools for a couple of years until the short half-life material decays, and then they would move it to a permanent storage site. And as you can see, hey, one day, son, all this will be yours. All this nuclear waste from all the nuclear power plants that have ever been running in the United States and the rest of the world is kept somewhere. And we don't have a place to store it for where it will be safe and secure for 100,000 years. This is a real serious problem. It's one that absolutely will have to be solved at some point, but right now we do not have a solution. This is one of the reasons that we moved away from nuclear energy because people realized in the 70s and the 80s that we don't have a place to put nuclear waste. We don't have any place that we had not thought of any place where we could store the stuff away safely for 100,000 years. And we're not just, risking ourselves, we're risking all of the people who are going to be alive for the next 100,000 years with this waste that we're producing in nuclear power plants. Now, to bring us up to date, the plan until, well, 25 years ago or so, 20 years ago, was for about 20 years ago now, was to bury the stuff for the United States in a place called Yucca Mountain. And Yucca Mountain is a mountain, there it is, in the desert out in Nevada. This is Las Vegas, is just this is North Las Vegas. So the city of Las Vegas is down here. This is Death Valley in California, so you can kind of get an idea of the scale of this. So kind of halfway between Las Vegas and Death Valley, out in the desert in in Nevada was the plan. This was near the nuclear test site where they used to set off nuclear bombs when they were testing in the 1950s. So the area is kind of contaminated with some radiation already. It's in the middle of the desert, and they said, hey, why not just bury it all there? So the plan was that they were going to drill into this mountain. They did drill into this mountain and mine into this mountain and go down, 1,000 feet, and in this stable rock layer. Um, and deposit the nuclear waste in there and then seal it up with concrete, and it wouldn't bother anybody for 100,000 years. Yay. So why did they pick Yucca Mountain as a spot? First off, it's way out in the desert where people don't live, and there's been no earthquakes there for like a really long time. So, I mean, what are the chances of there being another earthquake in the next 100,000 years? We'll get back to that. It's the desert. It doesn't rain very often, so you don't have to worry about like the mountain eroding away and exposing this stuff. And since it doesn't rain very much, that means that the groundwater at the site is thousands of feet underground. So you don't have to worry about groundwater carrying this stuff away from the site. This was the thinking at the sign. And it's far away from people. It's way out in the middle of the desert. And who likes going out in the middle of the desert? So people will never bother it. And this was the thinking behind choosing Yucca Mountain as the depository for United States nuclear waste. Now, not too surprisingly, people in Nevada objected to this. This is kind of the absolute extreme of NIMBY, not in my backyard. The people in Las Vegas, they're like 100 miles from here, and they don't want this nuclear waste that close to them. They objected. Yeah, what could possibly go wrong? And environmentalists also were objecting to this as well, saying that, hey, these assumptions, they're not very well founded. What could possibly go wrong? Well, for example, it only has to last 100,000 years. Well, what about climate change? Climate change is a thing now. So it doesn't rain there now, but could the climate change significantly in the next 100,000 years so that there might be erosion, so that the groundwater might be closer to the surface? I mean, let's think about it. We've had ice ages about every 20,000 years for the last million years or so. We're talking about 5 ice ages before this stuff is gone, and the climate could change significantly, and that might not be a desert in 20,000 years from now. It might not continuously be a desert for the next 100,000 years. The groundwater could start carrying things away. Erosion could happen. So yeah, climate change could be a problem. They said, hey, there haven't been any earthquakes there in like a really long time. Well, Fukushima. Fukushima is the nuclear disaster that happened in Japan because of the huge earthquake and tsunami that had not been forecast. They designed those nuclear power plants with the largest earthquake in recorded history in mind and the largest tsunami in recorded history in mind, with a margin of error when they built those plants. And it wasn't enough because there was an earthquake bigger than what they thought could happen. Uh, and they have a serious problem in Fukushima now. Um, and finally, and this, in my personal opinion, is the worst one of all, is that human beings are curious. And it seems fairly likely that somebody is going to find this thing sometime in the next 100,000 years and say, hey, wow, this looks kind of cool. I wonder what's buried in here. This could be like 50,000 years old. I wonder what the ancients hid in there. And then they'll dig it up. And that could be a problem because it's difficult to communicate through 50,000 years after civilizations fall and rise and fall and rise again. Um, Future archaeologists find this and dig it up and want to know what's in there. Now, do we have examples of this that are more rational than that? Yes, absolutely. How about the pyramids in Egypt? The pyramids in Egypt are about 5,000 years old. That's 1/20th of the amount of time that these things need to stay sealed up and undisturbed. Um, this 100,000 years, this is more than 10 times as long as human civilization has existed. Okay, we think at the extreme that human civilization goes back no more than 10,000 years, probably significantly less than that. The pyramids, like I say, are 5,000 years old. So the pyramids have existed for most of human recorded history. Um, Anatomically modern humans have been on Earth for about 100,000 years.